Station, this is Houston. Are you ready for the event?
I am ready for the event.
Google Zeitgeist, this is Mission Control Houston. Please call station for a voice check.
Scott, this is Mark. Eddie here.
I have you loud and clear. A little bit of an echo, but not too bad.
Well, I see you're in the Japanese laboratory with the little airlock behind you. I actually brought this module up to space on my third flight. And we're going to line some folks up here at the microphones. So why don't we start getting people up, because this is an opportunity for all of you to ask him some questions. But I'm going to start off and say, just how are you feeling today?
Feeling pretty good, although I just had an eye exam, so my eyes are dilated, but I can't see you guys anyway, so it doesn't matter. I'm just staring into a camera, but it is kind of bright in here, and that's why I'm squinting. But we had a busy day, did some medical eye tests, and getting ready for a spacewalk next week, so we spent a lot of time doing that.
And your first question is from?
Adam Getty. To keep your brother honest, he made a promise to you that we'd ask a question you've probably never been asked. So what's the one question you want to be asked that nobody ever has?
You know, it's interesting. I get a lot of the same questions over and over, so I get pretty good at answering those. And I had one space reporter a few months ago. Actually, his name is Bill Harwood. He asked me some tough questions about space policy and the budget and funding for commercial crew. And I kind of liked answering those questions. I can't think of a specific one that I've never been asked, but getting the non-standard, the questions we don't get all the time are the ones I kind of enjoy asking or answering more.
So Scott, the next question's coming from an Army guy, so I'm going to apologize in advance, but this is Kip Parker. And his
or try to use small words so the Kelly brothers can understand it. So I think I'm like a lot of people when we're going to unmanned aerial vehicles and driverless cars, everyone's wondering why we're still doing manned space flight. And I understand that it used to be that you could either have an unmanned flight or a manned flight. But now with work that DARPA is doing, the NIH, the Defense Threat Reduction Agency, now we have the in-between, organs on chips, where we can put parts of humans made from stem cells that can do various physiological functions. We can take data from them. We can make cellular computers. Have you ever thought about, or is anyone discussing the whole idea of exploring the in-between, between a manned space flight and unmanned space flight?
Hey, Scott, let me a second. I think
well, actually,
the other day, and we talked about this the other day, and what he's referring to actually is maybe you send parts of people. Is that correct?
Organs on chips, where you have specific parts of a human that are built from stem cells.
I'd never heard that, and actually I've never thought about that before. It is an interesting idea. When people talk about the advantages and disadvantages of human spaceflight versus robotics, things that are often brought up, and I would agree with this, and I think the people that do a lot of the robotics science, especially on Mars, will agree that so far humans are able to do a lot more work than robots. Now they, of course, need a lot more support, and you need to take care of them a lot better than you do robots. But the Mars rovers that have been operating on Mars for well over a decade now have done the amount of science that a few astronauts could have done there in a matter of days. So it's there are advantages and disadvantages to human exploration. I think certainly the just the romantic aspect of it, the fact that we are naturally explorers. I think the the motivation that provides for kids and their desire to be educated in the science is also a factor with human exploration. But the question you ask is really a great one, and one that I have never been asked before.
So he does win. Scott, the next question is from Alan Eustace, and Alan's a Google executive who jumped from 135,000 feet, only human, I believe, to ever survive being supersonic in a suit. So, Alan, go ahead.
So I know you do a lot of experiments up there, and I was curious about the experiments that you do. Do you know what the science is behind those experiments? And what's an experiment that you did that surprised you with an outcome in zero gravity that you wouldn't have expected?
Well, Alan, first of all, I'd like to say, I was really impressed with your feat, and I want to challenge you to someday jump off the space station and parachute back to Earth. That would be really exciting to see. So you can put that on your list of things to do. But as far as our, as far as the science we do up here, and knowing, what the science is and what the outcomes are, it just depends. There's throughout the course of the year I'm here, there's 400 different scientific experiments going on. Some of those go on outside the space station and are almost completely transparent to us. For instance, my brother brought up the alpha magnetic spectrometer that's looking for dark matter and, antimatter, and trying to figure out where, most of the mass in the universe is coming from. And that stuff goes from the, the sensor, the spectrometer outside into the computer in here and down to the ground for analysis. And we have almost zero interaction with it, although on a spacewalk next week, we're going to put some insulating blankets on it because the cooling system's not behaving properly. That's one extreme. The other extreme is, stuff that we are intimately involved in, which is mostly data collection on ourselves, like these eye exams I was doing this week. As far as how the data looks and, what we're learning from that, there is some involvement. I do get some feedback, but a lot of these things, like these scans we do, we have this laser scanning device for our eyes. We have a fundoscope. We have an ultrasound. All that data gets sent to the ground and gets analyzed over time. But I do have some understanding of what's going on. For instance, there has been some changes in my eye structure, similar to what I had last time on my 6-month flight. But there are, things that have happened with my, the optic nerve, the disc itself. And then as far as surprises of things that we've learned that I didn't expect, that's a tough question. I'll have to think about that one some more, but I will certainly get back to you.
Next question.
Hi, Scott. Josh McClure, Air Force Academy, 96. You're fulfilling a dream of mine and many of my friends. I'm working for a company called Health Anonymous, and we've been talking a lot about health here, and especially public health. You must have some sort of pathology lab or mass spec analysis or something up there. If you could tell us a little bit about the tests that you do to monitor your health. You must have some sort of personal dashboard, health dashboard, and that's a dream of ours, I think, to get a personal health dashboard and periodic testing. If you could tell us more about that, I think everyone would love to hear it.
Yeah, so we have a lot of devices, medical devices, like I was saying, the ultrasound, fundoscope, a laser device for our eyes. We do data collection for science with those. And then we also do things for our periodic health assessments. But those are pretty basic kind of things, like, taking pictures of our ears. We do vision tests that are pretty, fairly benign, like you might see in, when you go into your eye doctor. We do tonometry, which measures the pressure in our eye. We take our blood pressure. We don't do things like labs. We don't do blood work up here, although the Russians do have some capability to do some rudimentary stuff. But, we do take a lot of our own blood, and we do centrifuge it, but it's, sent down to the ground for analysis, and we do that, when we have the opportunity. And, again, that's mostly for scientific purposes and not health monitoring purposes. We haven't gotten to the point where, we would have a device like you're talking about, maybe like, I understand that, the Apple Watch has some health monitoring capability. We haven't quite gotten there yet. We do this VO2 max test, so you'll have, electrocardiogram on while you're doing exercise cycle ergometer to measure our cardiac health. But kind of like a personal dashboard type thing where you get a lot of maybe real time and continuous monitoring of our health. We don't have that yet.
I think what happens is they try to get him in a pretty good spot before he launches, and then he's on his own. So then, what happens, and a year later, you're going to come home. Something gets really bad, kidney stone, where you have a major issue, there's always the option of leaving. Next question.
Hey, Scott. Jimmy Crawford, Orbital Insight. So we had some really interesting talks yesterday about North Korea and presentations from some folks who had grown up there and then immigrated to the U.S. and told some amazing stories. So I'm really curious from your very perspective, do you see a difference when you look at North Korea versus South Korea or the other areas in terms of how developed it appears from the space station? Do you see the difference in the nighttime lights that we see in some of the satellite pictures with your own eyes?
It is shocking in, how the situation is so bleak over there for those people, from what we can see here, especially with regards to, their electricity. Pyongyang from space looks like a little smudge of light, a speck in the ocean of darkness, which is North Korea. And you see that compared to Seoul, which is, just to the south. And, it's just like night and day. And it's, it's sad to see. During the daytime, when you look at North Korea, surprisingly, it's very, the air doesn't look very clean, but it's pretty obvious it's not from North Korea industry. It's from a lot of the pollution that just gets blown over from China. So, not only do they not have electricity, but they are also, have, crappy air because of the pollution that China generates. It's really a bad situation all the way around, and like I said, very shocking to see with your own eyes.
Hi, my name is Niccolo Di Masi. I run a public company that makes games called Glue, and I've got a lighthearted question and a more serious one for you. The lighthearted question is, do any of you actually kill time by playing games on the space station? And the more serious one is, do you think a round trip to Mars will lead to any permanent physical side effects, or will it be something that can be sustainably done numerous times for an individual?
So, none of the crew members up here now play any kind of games. I know we've had people in the past play electronic chess with people on the ground. We don't have any. We do have the capability, with our laptops to have some video games. We have, we have iPads, and I'm sure there's some games on here. We actually use Google for our browser for our timeline, and there are games on there, but I personally don't play them. We're really, really busy up here, and there's very little spare time. And the spare time I do have, I generally, look out the window to take pictures of the Earth, or, watch a movie or some sports or something, or read. And also, we spend a lot of time on email and on the phone. As far as the round trip to Mars question and doing it multiple times, there are some challenges to going to Mars. I think they're not things we can't overcome. But, one of the big ones is radiation. And, on my first flight, which was to the Hubble Space Telescope, which was about twice the altitude we're at now, in 7 days, I there at that altitude, I got almost as much radiation as I've gotten, or I'm sorry, half the amount of radiation as I've gotten since I've been here since March. So it's about 10 times the amount of radiation. My lifetime radiation that I'll get over the course of being in space for 500 days, mostly at this altitude, protected by the magnetic field of the Earth and the Earth's atmosphere, will give me a 1% chance of dying of cancer as a result of that radiation exposure. So if someone going to Mars is going to have, 10%, 20% chance, and, to do multiple trips, you would, without finding a very practical and very, efficient, a good way to protect them from the radiation is going to have, there's significant radiation effects that we're going to have to deal with that I think, is possible, but, something that definitely needs some forward work.
Scott, I'm going to jump in here for a second. So as the American who has now spent the most time in space, what do you think about the prospect of somebody, not necessarily you, but as an individual making a one-way trip to Mars with the plan of living in that harsh environment and never having the opportunity to go home?
So, if I was a little younger, and it was something that would, have worked out for me, and, eventually someone's going to go to Mars, I would definitely love to be part of that mission, would be a volunteer, would be willing to do it. I would not be willing to go on a one-way trip to a destination where you are going to spend the rest of your life in a in a closed environment or in a spacesuit when you go outside. Besides, having been up here now for over 200 days, besides the personal connection you miss with people on Earth, the next thing I miss is going outside, the freedom to, walk out my front door, feel the sun on my face, the wind at my back, put my feet in the grass, those kind of things is something that I definitely would not want to live the rest of my life with. I could do it for maybe a few years, but I would never dream of giving that up.
Hi, Scott. My name's Louis Cole. I run a popular travel adventure daily vlogging channel on YouTube. I actually spoke to you, via a video message earlier in the year in May. NASA approached a few vloggers. It was hosted on the NASA website. I don't know if you remember, but it's an honor to actually have a live chat with you now. My question is, I imagine the thought of returning when you do back to Earth, there's a lot of positives and it's exciting, and I'm sure you're looking forward to it. But is there anything that you fear on maybe psychological or health, or is there anything you fear about coming back?
That's an interesting point. I just started thinking about coming back recently. I tried not to, for a long time. And, it's, people that have been in situations, where they can't go home have given me the advice that, you don't want to count down, you want to count up the number of days. But it has entered my mind. And I think, I've been here over 200 days, and it seems like I've been here a really long time. It's almost like I feel like I've forgotten what it's like to live on Earth. And I do feel a little bit apprehension of, what it will be like to get adjusted, even though I really look forward to it. And but I think there will be an adjustment period, and it does give me a little bit of an apprehension for what that will be like. The last time I flew a long-duration flight, it was 159 days, about 6 months, and it took me about 6 months to feel back to normal, getting back into the routine of a your daily life, where it's kind of up to you to decide what you're going to do. I mean, we have this timeline here with a line marching across the screen, and it shows us what we're going to do in like 5-minute blocks. Some of the activities are much longer than that, but it's basically telling you what to do all the time, and then you get home and you don't have this. I think in a lot of ways it might be like how someone who's coming out of prison has an adjustment period, and in some ways they're more comfortable in prison because their life is so regimented, and they've gotten used to it. So I'm not worried about the physical part of that, but I am starting to think a little bit about psychologically what it'll be like leaving this environment and going back to one where I have much more freedom.
Taylor.
Taylor Wilson here. I just wanted to ask a little bit about the radiation environment on the ISS. I know it's low Earth orbit and you're shielded by the Earth's magnetic field, but do you have a shielded section or semi-shielded section, and what are kind of the dose predictions over your mission? That was the first question. If I can ask a second one, it would be, what are some of the experiments you're working on right now as part of the ISS National Laboratory System, and maybe what's the most interesting one?
Yeah, so there are certain areas that the only areas that are actually, we're shielded by design are our crew quarters. Have some special, we call them bricks, but they're radiation absorbent material in them to give us more radiation protection while we're sleeping. And one of the crew quarters that the Russian guys stay in doesn't have those. So that person actually gets a lot more radiation than the guy that's just sleeping across the hall from him. Don't ask me why it's like that, but it is. And you can see it in some of their radiation monitors. They have these certain monitoring devices that's like a gel, and you can see these specks that are where this gel got radiated. And if you're the guy that lives without them, you can see what your gel is getting along with the gel in the test tube. So the dosage we get, I'm trying to recall what the units are. I don't want to be wrong, but I was thinking millirem perhaps, and you can correct me if I'm kind of completely out to lunch there. But I think over the course of the 6 months I've been here, or 7 months so far, I've gotten about 50 to 60. And correct me if I'm wrong on the units, please.
No, I think it's millirem, so yeah.
Is that like Chernobyl radiation?
Yeah, it's not.
And the second part of your question about the National Laboratory, a few months ago, seems like an eternity ago, we did a lot of experiments with some rodents, mice, and some of those rodents were National Laboratory rodents, and we dissected them, euthanized them, dissected them, and removed their organs. Some of the stuff, some of their bones, we X-rayed up here while they were still alive, see what kind of bone loss they were experiencing, and then we're sending samples back to Earth. Some of those are for a biotech company. Some of the research, the National Laboratory research was, and some of it's NASA research, more dedicated to understanding what happens to us in this environment for exploration purposes, versus the National Lab that's more about improving health on Earth and for the people on Earth.
Meredith.
Hi, I'm Meredith Perry, and I've always wanted to go to space, and I will hopefully before I die. I also have two questions really quickly. Do you think that prolonged periods of time in zero gravity many years is something that humans could get used to? Or do you think that if we actually end up living in actual outer space, we'll need to simulate gravity by spinning the spacecraft? And why don't you guys spin the spacecraft at all, just to give you guys a break every now and then? And then my second question is, how has being, sorry, not that kind of spinning, you know what I mean? How has being in space for such a long period of time changed your perspective on life?
Yeah, so that's a few questions, and if I don't hit them all, just ask me again. But we've talked about that. It would be more convenient and more efficient to have gravity up here. So many things that you do become so much more complicated because you can't put anything down. You got to Velcro stuff to the wall. You lose things. Things float away from you. Although you get better at it, it's something that you just have to learn to manage. And a little bit of gravity, not Earth's gravity, but a little bit of gravity, keeping stuff where it needs to be would go a long way. The systems could be designed more easily, perhaps, with some gravity. Why don't we do that up here? I think it's just the the engineering complexity of it, and the fact that just making things more convenient for a space station like this is probably not a good reason with regards to maybe the cost that it would take to do that, which I'm not sure what that is. As far as us physically, you do get used to living up here, and sometimes I think I feel completely normal, but then the next day I think I don't. I still feel some stuffiness and swelling in my head at times. Your digestive system, some days it feels okay, and other days not. Gravity is very important for how it not only allows us to keep things where they need to stay, but also push things where they don't need to be. So, and could you live like that for a long period of time? Yes. Would you like to live like that for a long period of time? Like years? Maybe not. It's probably somewhat person dependent. Did I miss one of your questions?
Why is it so complex to spin the capsule in space? Because my understanding is that if there's no friction in space, then if you just kind of give it that initial push, it'll just keep spinning, right?
Well, yeah, that's true, but it would definitely affect the the usable volume of the spacecraft. I think you'd need a really big moment arm, or you're going to have a pretty big gravity gradient. Like if I spin my body, I might have a lot more gravity at my head than I will right in the middle. So I think for that to be a usable solution, it would take a very large spacecraft to then have that usable volume. But this is just me thinking off the top of my head to answer your question. Maybe my answer is wrong, and maybe you could spin this space station, and at this end, let's say this is the longitudinal axis of the space station. So about 100 probably about 150 feet down in this direction is the Russian segment. So if we spun it around this space station around the center of gravity, I could, be walking, on this wall with a little bit of gravity, but, halfway towards the Russian segment, we'd be completely floating. Maybe that's a practical thing to do. It's, I think, something that NASA hasn't really considered because it hasn't been required for us to do our mission. But it's definitely a good idea. And, I think if people lived in space for a really long period of time, it's definitely is something that would be more than just a nice to have. I think it'd almost be, a requirement if you were going to, go on a mission for, a number of years or, live in space permanently.
Hey, Scott, we're going to lose you in about 10 seconds. I want to thank you for your time. I know you got a lot to do, but thank you very much.
Well, it's my pleasure, and hope you guys, everyone, continues to enjoy the conference there. Thanks for joining me on the space station.
Station, this is Houston ACR. That concludes the event. Thank you.